This is a tutorial for the bonding and Bohr-Rutherford diagram simulation. This is just an interactive version I made to make Bohr-Rutherford diagrams. So the idea here is you can click on any one of the first 20 elements like magnesium with, a mass of 24 and an atomic number of 12. So the first thing you can do here is, this is like a proton dial, so you can go up to 12 there, and you can add your 12 neutrons to get a total mass of 24. And when it's time to add the electrons, you just click on New Shell, and then there are little spaces here that you can add them individually, or you could also just click that to fill the whole shell. And when you want the second shell, I know this one's going to need 8, so I'll just click that to fill the whole shell. But if you want, you could have your students do, top, left, bottom, right, or whatever order you teach it. And then a new shell, and if you go top and bottom, or if you go top and right, it will tell you that you got it correct. If you go top and top, though, it actually will show you that it's not correct. So it will tell you if you're wrong or if you're right. So that's building Bohr-Rutherford diagrams. Bohr-Rutherford answers is just a mode where you click on it and it gives you the final answer immediately, so you don't have to make it. Okay? Bond mode is entirely different. This lets you make molecules and salts, actually. So if you wanted to make, let's say, magnesium chloride, so you drag a magnesium and you drag a chlorine here, and you can just take that electron and just put it there, and you can take this one and, I guess we'll need another chlorine. You can just take this one and put it here, and, put it there. And there you go. So if they're highlighted yellow and they're kind of glowing like that, it means you're done. It means they are stable ions. And so this is our magnesium chloride salt. I'll hit reset. Now there is one option if you're doing like aluminum nitride, let's say, and you want to put this one up here. You can, if you hit this, it rotates where the single electrons are, if you decide that's going to be helpful for you. I guess for aluminum nitride, it won't matter. For anything ionic, but for covalent ones, it will matter more. So, I guess aluminum nitride just needs one of each. So there you go. We're finished with aluminum nitride. The other thing that we can make are covalent bonds. So if you wanted to make, let's say, methane, here's my carbon. And here's a situation where I want that electron to be on the bottom. So if you hit that twice, it will be on the bottom. And what you can do is you can just loop them like that, and it becomes a shared pair. Likewise, this electron I want to be on the left side. This one's good on the top. And that one's fine. So there we go. I have my methane molecule right there. If you click on Random Build, it just gives you a random ionic compound or organic molecule to create. I don't know if you saw that there was a glucose there, which is a little too complicated, but maybe we'll make C2H2O. Why don't we try that? So we'll single bond those carbons, and we'll put an oxygen. We'll double bond that oxygen. And I got 2 hydrogens, so I guess I'll double bond the 2 carbons there. So it's got a few, there we go. It's got a few random builds in there. I don't remember if they get much more complicated than that. No, I don't think they do. I didn't go too crazy. I think I saw a glucose in there, which is going to be tricky. Oh, maybe there wasn't. Yeah, there it was. I thought I saw one. Regardless, you could have the kids, you could just write it on the whiteboard, whatever you want them to draw. So this is another option that you could have the whole class. You could have one student doing this on a smartboard if you have one, and have the whole class give them feedback. So that is the Bohr-Rutherford diagram and bond simulation. Oh yeah, if you click that, I guess just hit a little reset to get rid of those ones and restart. Hope you found that useful.